everybody. My name is Abigail Cargill. I'm a graduate student in the School of Environmental and Forest Sciences. And today I'm going to talk to you about preventing PFAS water pollution with phytoremediation. So just to review, PFAS are a class of chemicals that are used in things like paints and coatings, cleaning products, firefighting chemicals, which I'm going to focus on today, surfactants, electronics, and a bunch of other products. They are ubiquitous in the environment, which means they've traveled throughout the environment, even to very remote locations, and that's partially because of how persistent they are. Because of some of the issues with PFAS, companies have tried to create newer forms, but unfortunately, those forms are made up of smaller molecules that actually travel through the environment even faster. PFAS are suspected carcinogens, they're toxic, have high bioaccumulation potential, and they're extremely persistent. One of the reasons for this is that they are aliphatic, which means partially hydrophobic and partially hydrophilic, so they can dissolve in pretty much any substance. There have been many events of PFAS pollution in the past. One that I think we've touched on in class is the Teflon contamination that is discussed in the movie Dark Waters, and that's an absolutely fantastic and fascinating movie that you guys should check out if you want to know more about a specific PFAS issue. So the site that I'm going to be talking about today is the Kitsap Bangor Naval Base. It's that red outlined area in the center. You can see where it is relative to Seattle. So it's pretty close. It's kind of out where the area starts to get more rural, but there's still people that live on and around the base. And they have been impacted by this PFAS, or PFOS and PFOA contamination. So the contamination source was firefighting foams that have been used for testing and training exercises on the base. Over time, they've leaked into soils and groundwater. So the naval base decided to conduct some tests. I don't actually know what the cause of the first round of testing was, but they decided to test a bunch of wells around the base. They sampled a total of 292 homes. 83 of those homes were positive for some amount of PFAS, and 2 had PFAS above the EPA-advised lifetime limit of 70 parts per trillion. You can see in the map on the right where the problematic areas were. So the 2 wells that had contamination above the lifetime level are in that south area, but there's wells in all of the areas that had at least a little bit of PFAS contamination. And so what has the Navy done so far to respond to this? They're expanding testing into more areas around the base, and they've provided bottled waters to those living in the contaminated areas, but only to the 2 homes that were above the lifetime health advisory. So all these other homes are still drinking water that's contaminated with PFAS, just at lower levels than what's considered highly dangerous. Traditional approaches to treating PFAS contamination include cleaning up the soil by removing it and treating it with harsh chemicals and then returning it back to the original location. If the contamination is in the water, it often has to be pumped to the surface and treated, or oxidative chemicals are injected underground where they can react with the contaminants. There are also some advanced technologies like filtering devices and special polymers that can capture the compounds, but the problem with all of these traditional approaches is that they're treating the issue after it happens. And in my opinion, the next step in protecting the environment is actually to be proactive and to prevent these contamination events instead of simply responding to them after they happen. And one of the proactive approaches that has been growing in popularity in recent years is phytoremediation. Basically what this means is using plants to degrade environmental pollutants. Typically we use plants like poplars and willows, because these trees have extensive root systems that spread both deep into the ground and wide around the tree, so they can capture pollutants from a very large area. We can also use grasses. Phytoremediation is adaptable to almost any situation, and it is assisted by rhizosphere microbes, so microbes that live in the soil and interact with the root system. Typically, phytoremediation is much cheaper than traditional approaches. There's several types of phytoremediation, including phytodegradation, extraction, volatilization, rhizosphere-assisted degradation, phytostabilization, and hydraulic control. And what we're going to talk about is an example of phytodegradation. So there's been some preliminary work in testing different types of trees and plants in PFAS remediation. This research is in pretty early stages, so the remediation isn't 100% effective, but trust me when I say that these technologies, when they're fully developed, can be extremely effective and degrade 90% or even more of the target pollutants. So on the left, we have an example with willows, accumulation and effects of PFAS in 3 hydroponically grown willow species. So they looked at the foliage, the root, and then the total whole plant, how much PFAS had been taken up. And in the most effective clone, that middle gray one, S. purpura, they achieved 11%, approximately 11% removal of PFAS. On the right, they used a type of reed grass and did the same thing. They measured uptake of PFAS in shoots and roots, and then the total in the whole plant, and had fairly similar results with 10% reduction after day 14, and by day 21, 11-ish% degradation. So again, these might not seem like big numbers, but for the early stages of remediation, this is a pretty good start. So if we were to implement this at the Kitsap Bangor base, what would that look like? We'd have to consider first what we're going to plant. So do we want to plant poplars or willows? Do we want to plant those reeds that I had talked about previously? Or potentially, do we want to explore the possibility of a genetically engineered plant? There's a lot of regulatory hurdles to jump through for genetically engineered plants, so they tend to be avoided at least right now in phytoremediation, but there's definitely future opportunities in that area. We would then consider where to plant, and there's 2 options in this particular case. The first would be to plant a buffer along the entire southern part of the base. That would essentially separate the base from the rest of the surrounding area, and as pollutants were running through the soil out of the base and into that surrounding area, they would be captured in the root systems of the trees and then hopefully degraded by either the tree or the microbes. The other option would be to plant that same sort of buffer, but just around the testing area where they're releasing those firefighting chemicals. And this would hopefully prevent contamination even within the base and would just keep those pollutants trapped very closely in one central area. And then they would be degraded by the trees before they could leave that area. Also, we'd have to consider the cost. Just as an example, poplar trees can range anywhere from $5 to $30 per tree. And overall, the cost of a phytoremediation project tends to be up to 10 times cheaper than using traditional methods. Poplar care is pretty simple. You just monitor the tree health to ensure that the trees respond well to the pollutants that they're trying to degrade. And with poplar, there's an additional option to do something called coppicing, which is essentially taking a big pair of scissors, chopping off the tree at its base, and leaving the stump in the ground. A new tree will sprout out of this stump within a year, and the biomass that was harvested from above ground can be sold, used for firewood, used for energy at the base, and can generate an additional source of income. So in conclusion, phytoremediation is an effective method for removing pollutants from soil and water. Phytoremediation can be proactively employed to prevent future contamination events. And planting poplar trees at the Kitsap Bangor Naval Base will prevent PFAS from leaking into the surrounding environment and will protect the health of families living on and near the base. Here's just some references if you want to do any further reading about this. Thanks for listening, and I'm very excited to continue this discussion with you in class.